Good morning everybody and welcome to our presentation on volcanoes. Okay. A few definitions to get us started. A volcano is a conical hill or mountain formed by material from the mantle being forced through an opening or vent in the Earth's crust. And volcanicity is a general term used to describe a range of volcanic activity often associated with a place or region, including volcanic eruptions, geysers and hot springs.
Right, so first up we've got hotspots. So first of all, radioactive decay of the Earth's core generates hot temperatures. If the decay is concentrated, then hotspots will form. The lower mantle is then heated, creating localized thermal currents where plumes of magma rise. These plumes of mafic lava then burn through the lithosphere to create shield volcanoes. Hotspots do not move with the plates above, so a chain of active and extinct volcanoes is created as the plate moves over the hotspot. So these are predictable Hawaiian eruptions which occur. Right, so next up we've got fissure volcanoes. So these occur at elongated splits in the Earth's crust at diverging constructive plate boundaries to allow mafic or basaltic lava to spill out. So mafic lava has a low viscosity due to 50% silica content. Therefore, gas can easily escape and pressure is not built up. The resulting Icelandic eruption is predictable, frequent and not very explosive.
Okay, now we have shield volcanoes. These are associated with mid-ocean ridges, rift valleys and hotspots where magma has direct access to the surface. They have runny lava and gently sloping sides. An example of this is the Hawaiian eruption, which we have here, which has basaltic magmatite. This is the Kilauea volcano in Hawaii, which is the #1 most active shield volcano in the world. Strombolian volcanic eruptions are also examples of shield volcanoes. Icelandic eruptions are also as a result of basaltic magma in this way.
Composite cones are your typical volcano that are formed from alternating eruptions of tephra, which is ash and lapilli, so material ejected by the volcano. And they create different layers of materials which result in the building up of the volcano over a long period of time. So as you can see, that layer of material would have been the most recent eruption. And they're also covered in many secondary cones with their own little layers of tephra, ash and lapilli. So we can see that this secondary cone would have erupted much more recently than the main vent over here by the different layers over here. They have antecedent lava, which is medium viscosity due to a 60% silica content. An example of a composite volcano. No, usually composite volcanoes erupt with explosive eruptions such as Vesuvian eruptions. An example would obviously be Mount Vesuvius in Italy. They tend to occur.
Dome volcanoes, their lava is viscous and the volcanoes are often steep-sided. The rhyolitic lava cannot travel far and therefore often gets stuck in vents. This means that future eruptions are explosive and unpredictable. An example of a dome volcano is Mount Pelly in the Caribbean. Its infamous eruptions are deadly, explosive pyroclastic flows. This is an example of a Pelian eruption.
Supervolcanoes. Supervolcanoes occur when there is a massive hotspot, as Colin just said earlier, and when it builds up underneath the crust, and the crust can't take it anymore, and the crust kind of collapses, and lots of gas fizzes out, and many thousands of times more material than a normal volcanic eruption is erupted and expelled out of the volcano. They do not usually have mountainous appearances, as we can see here. They usually are seen as an indent on the Earth's crust, from where previous eruptions have occurred and the crust is sunk in a little bit. It's called a caldera. You can see the edge of the caldera. just there. There's always a huge pool of magma underneath the caldera where the next eruption is waiting to happen. They're very infrequent. However, Yellowstone National Park in the USA is an example of a hotspot, and that's due to erupt imminently. The heat from the magma causes many geological features, such as thermal springs and geysers, which is where the lava superheats water which shoots out from underneath the ground.
Here we have a table with the different types of lava and their different silica contents. We can see as the silica content rises,
Look at the table.
the viscosity actually increases, and the gas changes as we go through. So it goes from bubbled through to difficult to get through to completely trapped. Also, the different rocks change as well. So 50% is basalt, and then as we get more silica content, they are granite.
Right, so finally we've got another table which is showing the type of lava and where they would occur and on what boundary and eruptions. So, yeah.
On the table. Take it to the table, please.
Alright then. So first off you've got mafic or basic lava. So that's going to have a lower 50% silica content, so therefore a very low viscosity. So gives you what kind of volcanoes they occur at, which is fissure or shield volcanoes, and then their eruptions, and which boundaries they occur at, and how they are very predictable ones. So as you go down, intermediate lava is more explosive, it's got higher viscosity than basic lava, and tends to be at constructive, converging destructive plate boundaries. Then finally, there's a really explosive one, it's rhyolitic.
Cataclysmic.
Cataclysmic ones, as I might say. So that's rhyolitic lava. So it's got 70% silica, very high viscosity. And they're super volcanoes or dome volcanoes. And as Ben said before, they're Pelean eruptions or Plinian.
Thank you very much. Probably your